Problem 20. How many ordered pairs a comma b such that a is a positive real number and b is an integer between 2 and 200, so b is within 2 and 200, satisfy the equation of that? Well, first thing to notice here is that if we can write, the minute I read this, right, I think of log base b of a, because we all share this term. If I can write a in terms of b, then I can basically solve the question, because I know the number of distinct values for b, and there's always going to be a corresponding a for every b. For example, b is equal to 2 will correspond to one a, b is equal to 3 will correspond to another a, and you see where this is going. So now, let's first simplify this expression. Log base b of a to the 2017 is equal to log base b of a to the 2017. Now, this is equal to 2017 times log base b of a. Don't make the mistake of saying that this is also equal to that, because remember, exponents represent multiplying this quantity 2017 times. But this stands for adding this stands for adding a 2017 times, because once you break this up, it's going to be log base b of a, right, times a times a times a, and we can break this up into log base b of a plus log base b of a, but we do this for 2017 times, which is why you can write this as this, and you cannot write this as that. Don't make the mistake, guys. So this is going to be equal to log base b of a raised to the 2017th power. I share a common term right here, so I hate writing it in terms of log base b of a, so let's write it instead as x. Let's assume log base b of a is equal to x. If that's the case, then x to the 2017 is 2017 times x. If we divide x on both sides, x to the 2016 is 2017. So x is equal to 2017 raised to the 1 over 2016th power. But x, again, is log base b of a. So what can we say here? We can say b raised to the 2017 raised to the 1 over 2016th power is going to be equal to a. But what is one thing to notice here, right? What is one thing to note? This quantity, right, has multiple solutions, because you cannot think of it as just 2017 raised to the 1 over 2016th power, because we're trying to find all solutions, and we know that log base b of a could equal log base b of a times 2017, and this raised to the 2017 if this entire quantity is equal to 0, right? If this is equal to 0, we know that 0 is equal to 0, and we know that a negative number is equal to a negative number, and we know that a positive number is equal to a positive number. And I only consider this is because what is the log range? The log can have a negative value or a positive value, and 0 in between. So we must consider all possible outputs of a log function to determine all possible values of this question. Right? That should make intuitive sense. So this is the case where what? This is the case where the log is larger than 0. That's the case here. But then we must consider the case when the log is equal to 0. If log is equal to 0, then a is predetermined. A must be equal to 1, right? Because remember, it's log base b of a. So therefore, for all a is equal to 1 will correspond with all b's that has the range of 2 to 200. So this is going to give us a total of 199 distinct coordinates, because there's 1, 2, 1, 3, 1, 4, 1, 5. Basically, the number of coordinates will be the number of b values from 2 to 200, and that's 199 of them. Now let's consider the first case. That's going to be also 199, because b is going to be equal to 2, 3, 4, 5, and each of them, once you plug it in, will give a distinct value for a. So you have 199 distinct coordinates, 199 right here, and then you must consider the case where log is less than 0. Right? And you can think of this, right? Because the log will look like this. It could be negative, it could be positive, it can be 0. Right? Just think of a graph like ln x. So now let's go back to the question. If it has to be negative, then we can set this term right here to be negative, to 2017 raised to the 1 over 2016, right? And then we will set this equal to log base b of a, and then again, it would be symmetry to the first case. Therefore, you will have another 199 terms. So you multiply this by 3 to get 3 times 199, and simple algebra, right? Do this, so 597 would be your final answer, and that would be answer choice E.